I want to begin by taking a look at the homework that was due today. These are the AP problems that I assigned as homework, and I'm going to go through each one by one to make sure that you have a full solution. So starting with problem 23, the question becomes, what is the weight of an 85 kilogram person? We're going to draw a free body diagram of that person standing on the ground, including a label of on the forces. So we are on the ground, so what that automatically means is that we have a normal force, meaning a perpendicular force pointing up, and we have the weight force pointing down. Now, other ways that we could write this is we could write this as mg. The AP would also accept the letter capital W for weight. So just to be clear, you could write FG, W, or mg as any of those values. And let's be really clear, to actually calculate that weight, that's FG equals m times g, which is going to be 85, and we're going to use 10 for gravity. So that's going to give us 850 newtons. And I should be really clear. I said 10 for gravity. What I should really say is 10 for the acceleration due to gravity. So if I want to be super clear, Fg is the force and g is the acceleration. And both of these would be due to gravity. So let's get those terms really straight as we are doing this work. Next, a wooden crate is being dragged along the floor to the right with a tension of 60 newtons being applied at 40 degrees above the horizontal. We do have friction, and we want to draw a free body diagram of the crate, and we're going to label it. So we're going to have this, I'll call it F subscript T for the tension, and I will actually note that this angle here is in fact 40 degrees. Next, I will draw the weight force, Fg. There will be a normal force from the ground. And let's remember that the normal force in this case does not exactly balance the weight. It's the normal force in the upward component of the tension. And then we have a friction force right here. So that is the labeled free body diagram. Now it says if the crate of the previous problem is not accelerating, so let's be really specific. What that means is that in the x direction, fx equals 0. And remember, that's a formal algebraic sum. Dan, you and I talked about that last class, where we have f pointing in one direction, even though we're subtracting the force of friction. It's a formal mathematical sum like we do in calculus, and we want to know the value of the friction force. Once again, follow the process that I'm giving you here. It'll really save you effort later. So I'm going to set up equations that are in fact actually useless in this particular problem, but useful in the greater context of the AP. So what I mean by that is we're going to set up equations in the y direction. And what I mean by that is here on this label here, we're going to set up Fy equals Ft times the sine of 40. And in the x direction, we're going to have Ft cosine of 40. That's going to equal Fx. And so when we set up these equations in the y direction, the first thing I'm going to note is that Fy plus the normal force minus mg equals 0. And so I'm going to get very specific. This is going to be 60 times the sine of 40. I'm getting these numbers from up here, plus the normal force, which is unknown. It's not equal to mg. Please be careful with that. Minus m times 10 equals 0. So what we notice here is that it's not possible for me to get the entire normal force here. So I'll solve for what I can. So Fn is going to equal 10m minus 6 times the sine of 40. Again, let's not be perturbed by the fact that we can't exactly figure out what this force is supposed to be. Let's just calculate what we have. So that'll be 60 times the sine of 40. And that's going to give us 38.6. Okay, now normally we'd plug in m and we'd have a nice number. Now let's look in the horizontal direction and see what we're given. So we're going to say 60 minus the force of friction. Sorry, let's try this again. See, I made the classic mistake. I used FT diagonal right there. Let me set this up carefully. This is what happens when even I'm in a hurry. So the x equation is going to be F in the x direction minus the force of friction equals 0. Remember, we never use the diagonal force. We always use the force components in our x and y equations. So this is going to be 60 times the cosine of 40 minus the force of friction equals 0. There's no acceleration. And so what we're going to end up getting is that the force of friction equals, when I put 60 cosine 40 into my calculator, I'm going to get probably around 45. Yeah, 46. I'm going to round this to 46 newtons. And that's the answer we're going to get. All right, it says list the contact forces we have discussed and action under distance forces we have discussed. We haven't discussed this very much, but I'm going to actually give you a list of the forces that I mentioned this very briefly. This is not on the AP, but it's good to have this list. And in fact, I'm going to go ahead and, wow, how do I change the font size on this thing? Ah, you suck. Terrible program. Really? Here. Oh. Yeah. Smaller. There we go. Look at that. Oh, that was beautiful. Oh my gosh. All I want to do is solve this problem, but apparently that's just too much for you, science. Actually, I should say technology. Thanks, Steve Jobs. All right, here we go. List the contact forces we have discussed. Well, Tim Cook, fine. It's been a while. List the action under distance forces. So contact forces. Those include friction, tension, normal forces, spring forces. Okay. And the one action under distance force we've discussed is gravity, the gravitational force, meaning it's invisible from our perspective, and also electric and magnetic forces. Those are the two forces we're going to deal with next semester. So there's our idea. Now, here we have a 75 kilogram mass supported by 3 cables as shown. The cables are anchored to the ceiling, making an angle of 45 degrees. And we have 3 tensions labeled. We want to find the numeric value of T3. This is interesting because rather than drawing a free body diagram of the box, let's do a free body diagram of the knot. And that's going to give us T1, T2, and T3. Okay, that's fine. And now let's do a free body diagram of the box. So we have T3 pointing up and the box free weight pointing down. So that's going to be mg. So right here, I'll use the second free body diagram to note that in the y direction, T3 minus mg equals 0. And so that's going to give us T3 minus 75 times 10 equals 0. So that's T3 equals 750 newtons. Excellent. Now, we want to find the numerical values of T1 and T2. This is such a great little free body diagram. What I'm going to note here is that I have, let's use a different color. Let's use green. So we have T1 in the x direction, T2 in the x direction. And those clearly balance because they're the only x forces. Then when we have T1y and T2y, like that. So let's set up our y equation. That's going to be T1y plus T2y equals, sorry, I'm going to be clear, minus T3 equals 0. But we also have in the x direction that T1x equals T2x. So I'm just going to call both of these just plain old tensions. So I'm just going to say, let's call T1 and T2 equal to each other, and we'll just call those. Actually, I should be really clear. Let me put in more numbers and variables to really prove this. So that tells me that T1 cosine of 45 equals T2 cosine of 45. It's actually not guaranteed that the full tensions are equal, just the x components. These two things cancel, so that tells me T1 equals T2. I'm getting that from the x formula, and I can just set that equal to T. So now what I can say is that T sine 45 plus T sine 45 minus, I already got T3 as 750 equals 0. So what I'm getting is that 2T times the square root over 2, square root of 2 over 2, because that's the sine of 45, equals 750. And then I can actually isolate T, which equals T1, which equals T2, and that's going to give me a pretty straightforward number. Let me just do that right now. So 750 divided by the sine of 45 divided by 2. I'm getting 530 newtons for each of these. So that should be our answer. And let me just double check that one more time. Yep, so that times 750 divided by 2. Yep, 530 newtons is what I'm getting. All right, number 29. A 15 kilogram, actually, I think I'll just stop here with this first video, and I'll put up the second video with the rest of the problems on this page in. So I'll do this in 3 videos. This will be video number 1, 23 through 28. 29 through 32 will be the second video, and then 33 through 36 will be the third video.